Hello, welcome back everybody to Math 2413, more on math. Today we're going to talk about Chapter 3, Section 1. Section 1 deals with derivatives. Now, okay, it may sound complicated, but it really starts with this. From algebra, we remember this equation. It all begins with this. This is this equation for a slope. And what we're going to get to is we're going to define a derivative from here. All right, so also in algebra, we learned about functions. A function is the same thing as y. So in our equation, y2 is the f at x2 and y1 is the function at x1. So we have f of x2 minus f of x1, x2 minus x1. All right. Also in algebra, we determined that for any given curve or line or function, here's x1, here's x2, the distance between those two, we call it h. So to get from x1 to x2, x1 plus some value h will get us to x2. So anywhere we see an x2, we can rewrite it as x1 plus h. So f of x2 is f of x1 plus h minus f of x1. x2 is x1 plus h minus x1. You notice now we only have x1. We only have 1 point. So instead of writing x1, x2, whatever, we just write it x. So we have f of x plus any x we pick. We could start from there. x1 minus x1, these cancel. This also, but this equation in algebra had another name. It was called the difference quotient. What it did, it helped us find the slope at any given point, x1. So for example, if we had a curve, we pick a value of x, we could find this is the slope of the line tangent to the curve. But we did earlier with these equations, with our same equation, since our line crossed twice here, that line there, that's called the secant line. What we want is the tangent line, because that tells us the slope of a curve at any one given point. So this is where we're going to begin. So now, why is this important? As h is the distance between x1 and x2, as h goes to 0, that means these 2 points get closer and closer together. Eventually, x1 equals x2. They're the same point, and then we can figure out the slope. That's our whole objective. That's what this whole first section is about. Now, as I said over here, as h goes to 0, we call that a limit. Let me write it this way. The limit as h goes to 0 of our function f of x plus h minus f of x all over h. That is our limit function. Slope of a curve at any point, call it x of 0. Let's see this. Remember, this is a slope. So let's look at this equation. Y equals 3x plus 2. Remember, y is the same thing as f of x. So in our equation, we have f of x here. That's f of x. But now we need to have a function f of x plus h. What that means, here's our function. Anywhere I see an x, we put an x plus h. So here's the x. So I put an x plus h in place of x. So I have f of x plus h, f of x. So now I could look at the equation. The limit as h goes to 0, f of x plus h is 3x plus h plus 2. That's the first part. Minus f of x, which is this part. Now, since that's a minus sign there, we got to put the 3x plus 2 in parentheses over h. Because if you don't put it in parentheses, only thing that this negative does is just changes that 3x. It has to change everybody's sign. Alright, so let's get rid of the parentheses. We have 3x plus 3h plus 2 minus 3x minus 2 over h. Now, here's a checks and balance system. Anything after the minus, this here, they have to disappear. So here's the minus 3x, it cancels with the 3x. The minus 2 cancels with the 2. That's, if it doesn't, then you did something wrong. So everything after the minus sign has to disappear. So look what we have left. We have 3h over h. H's cancel, so we simply have 3. So what does this tell us? That's the slope. And sure enough, looking at our equation, we see this is a linear equation. Y equals mx plus b. Whatever's in front of the x is your slope. So that's how you test it. That's how it works. All right. Okay. Now let's see how this relates to what's called a derivative. A derivative is a slope of a curve f of x at any point x, or call it x sub 0. Since it's a slope, another description of slope is called a rate of change. A function at any time period call it the initial one. But that's what these are all saying. Now, the way you describe a derivative, the symbolism for derivative is either y, it's called y prime. That means a derivative. Or you can write f prime of x. Whenever you see this little tick mark, that means it's a derivative. That means if I give you f of x equals 3, then we know that's the slope, the rate of change. All right. Now, yes, we could go ahead and do that, the difference quotient every time, but I'm going to show you some shortcuts to do these things. We have two sets of rules here. Well, let me show you a shortcut first. So if we had a function equals 5x to the third plus 4x squared minus 2x plus 1, to find the derivative of this, since there are 4 different terms here, we can take a derivative of each one separately. The way you do this is this is the rule. If f of x equals ax to the power n, a is a coefficient, x to the power n. The derivative is a times whatever the power is to the power n minus 1, meaning you bring down the power and subtract 1 from it. So the 3 goes down here, so we have 5 times 3, so 3 minus 1 is 2. Four times 2, x 2 minus 1 is 1. There's a 1 here, so bring down the 1. 1 minus 1 is 0. And since this one doesn't have an x, it disappears. So we become 15x squared plus 12x minus 2. Because x to the 0 is 1. So there's our derivative. We have these sets of rules. If you have a constant, the derivative equals 0. If you just have an x, the derivative, if there's no power, it's just whatever's in front, the coefficient. If you have a coefficient, I mean, even if there's nothing there, it's a 1. The derivative is a, the coefficient, times the power, n minus 1. So that's what we just did up here in all those. Okay, so that's called the power rule. That's called the power rule. Right. So that's, now we have some other rules. What if your function, what if you had a polynomial function of f of x times g of x? This p of x equals f of x times g of x. This is called a product rule. The shortcut I'm going to show you is this. Remember this symbol there. We've seen it a lot of times in churches and stuff. It's a fishy symbol. So the way you do this You put the f function there, the g function there, and below it, you put the derivatives of each one separately. Now, this fish, you start from here and end there. So, like this. What it's going to be is g of x times f prime of x. Since you're multiplying, it's getting bigger, you add the other part. F of x times g prime of x. And there's the derivative of a product. So let's look at an example. 2x plus 3, x squared minus 1. Find the derivative. So again, looking at this, I call this f, and that's g. So f is 2x plus 3. G is x squared minus 1. F prime, the derivative of this. The derivative of a constant is 0. That's only the power 1. This one becomes 2. Now the derivative of g. The constant disappears. The 2 comes on front. And there's that derivative. So our derivative, since it's multiplying, we're going to add. Multiplying makes things bigger, so that's why we're adding. So we have these two. The g, which is x squared minus 1 times 2, plus 2x plus 3 times 2x. This times this, plus this times this. Now simplify. 2x squared minus 2 plus 4x squared plus 6x. Combine like terms. 2 plus 4 is 6x squared plus 6x minus 2. And there's your derivative. There's the equation. So if whatever x you give me, so find the slope at the point negative 3, 4. I would simply plug in 3 and negative 3 for x to find the slope. And we'll do that in a minute. Okay, so that's the product rule. The quotient rule. Quotient means fraction. So here's our polynomial here. Whatever's on top, we'll call it f. Whatever's on the bottom, we'll call it g. It's going to be the same thing. We're going to use the fishy, but since fraction makes things smaller, we're going to use minus sign. So we have f of x, g of x, f prime of x, g prime of x. So that's the first difference. Because it's division, it's going to make things smaller. Now, it's going to be the same thing. G of x times f prime of x minus f of x times g prime of x all over. Here's another thing. Whatever this is on the bottom, square it. And there you have it. Simplify it from there on out. So there's your derivative for the quotient rule. All right, let's look at this example. We'll use the same numbers. 2x plus 3, x squared minus 1. We know automatically that the bottom is going to be squared. Now, the only thing we have to do now is find the top. We'll call the top f and the bottom g. So f is 2x plus 3. G is x squared minus 1. You gotta find the derivatives. The derivative of 2x plus 3 is just 2. The derivative of g is 2x. So we have 2 times x squared minus 1, that's these two, minus these two, 2x plus 3. Two x squared minus 2. So I'll make this minus 2x. So negative positive is negative. 2 times 2 is 4x squared. Negative 2 times positive 3 is negative 6x. So that times 3. All over x squared minus 1 squared. Fix the top. Combine like terms. Negative 4 minus 2, so it's going to be a negative 2x squared minus 6x minus 2 and we could factor out a negative 2 on top, so we have x squared plus 3x plus 1 all over x squared minus 1 squared. And there's a derivative. Alright, so let's look at the homework assignments. Chapter 3, Section 1, homework. Alright, here it says, use the grid, make a rough estimate of the slope of the curve of these curves here. The slope of P1. So since it's a point on that curve, let's look at 2 points that go through there. So we'll go through this point to that point. Go 1, 2, 1, 2. So it's the slope. The slope is 2 over 2, which is 1. Now let's look at P2. Let's see, let's start from this one. Let's see where it repeats right there. So what I'm looking for is, see the curve where it crosses the x-axis, the horizontal line, the vertical line. I'm looking for one on this side and a similar one to the other side. All right, we'll look at this one. This is pretty close. And there's another one that's pretty close. So let's see the slope. 1, 2, 3, 4, 5 over 1. So it's 5 over 1, which is 5. That's estimate. So I said find points on both sides, and the average of those is going to be the slope. We're going to get from one point to the other point. Also, you can see here. So we only have these possibilities. So it's 1 and 5. Same thing here. Let's look at this one. Okay, estimate. It's not saying to find calculate it. It's find estimate it. So this point here, it's that close. So 1, 2 over 1. So it's 2 over 1 is 2. Alright, so that's the first sheet. Let's look at the second page. Find the equation. Okay, now we have to find the equation of the line, the tangent line to the curve. Let me see. Okay. To find the equation of the line tangent to a curve. These are the steps. 1. Find the slope. Remember, the slope is the derivative. You have to take the derivative at x. Use the point given and the slope and plug into y equals mx plus b to find b. Remember, b is the y-intercept. Then plug m and b into y equals mx plus b, and you're done. All right, so let's look at our example here. So the derivative of ours, since it's only one equation, I have a -2. I bring down the power and then subtract 1 from the exponent. So -6x squared. There's my equation of the slope of the line. Now, I'm looking at the point at -2. So y equals -6, -2 squared. -2 squared is 4. 4 times -6 is -24. So that's my slope. I plug that. Remember, my point I'm dealing with is -216. This is x, this is y, this is m. So 16 equals -24 times -2 plus b. We're solving for b. So 16, negative is positive, so it's -48 plus b. Subtract 48 from both sides. (48 minus 16) is -32. So that's my b. And there's my m. So my equation is m is -24 minus 32. So that goes in this box here. -24x minus 32. Now, since the slope is negative, that's not right. This is negative, that's horizontal, so it has to be b. Because the slope has to have a negative intercept of -32, has to be a negative slope, so that's it. Right, number 4. Find the slope of the line of that function at 614. Then find the equation of the tangent line. Pretty much what we just did there, but it's a fraction. So let's go over here. Chapter 3, Section 1, number 4. The equation is 7x over x minus 3. Let's first find the slope at the point 614. So A, we have to find the derivative. Remember, it's a quotient, so we take top is f, bottom is g. So we have f, g, f prime, g prime, and we have to do the fish. Since it's division, we have to subtract. So we know what the bottom is going to be. The bottom is x minus 3 squared. So the top is 7x. The derivative is 7. The bottom is x minus 3. The derivative is 1. So the fish is this way. So 7 times x minus 3 minus 1 times 7x. Seven x minus 21 minus 7x over x minus 3 squared. Simplify. The 7x's cancel. Negative 21 over x minus 3 squared. That's the derivative. That's your slope. Now it said at 6,4, so I use this x value. At x equals 6. So it's negative 21, 6 minus 3 squared. Negative 21, 3 squared, negative 21 over 9, negative 7 over 3. So that's my slope. So it's negative 7 over 3. Because they both have a 3 in common. Now, let's find the equation of the line tangent to it. 3.1.4b. We know the slope is negative 7 over 3. So I plug it into y equals mx plus b. Remember, this is the slope. So x and y, so it's 14 equals m is negative 7 over 3 times x, which is 6. We're solving for b. Reduce if you can. 3 goes into 6 twice. So negative 7 times 2 is negative 14. Add 14 to both sides. So b is 28. And m is negative 7 over 3. Plug those into y equals mx plus b. M is negative 7 over 3 x plus 28. And there's my equation of the line tangent to the curve. So it's negative 7 over 3x plus 28. All right, let's look at the next one. Find the slope of the curve at that. So let's first find the slope. The slope of negative 3x squared is negative 3, bring down the power, and subtract 1. So it's negative 6x to the first power. At x equals 4. So negative 6 times 4, negative 24. Find the slope when x is 9. So remember, this is f, that's g. The only thing we know for sure is the bottom number will be squared. So we have f, g, f prime, g prime. The top is 1. The bottom is x minus 5. The derivative of a constant is 0. Derivative of x is 1. The constant goes to 0. So 0 times x minus 5 is 0. Since it's a fraction, you subtract. 1 times 1 is 1. Negative 1 over x minus 5 squared. When x is 9. So negative 1, 9 minus 5 squared, negative 1, 4 squared, negative 1 over 16. That's the slope. All right, number 7. Find the point xy at which the graph has a horizontal tangent. Okay. Let's see what that means. 3, 1, 7. Horizontal tangent. If we have a curve, up here it's a positive slope. Over here it's a negative slope. Over here but what happens at the vertices? That's a horizontal tangent. What's the slope of a horizontal line? The slope is 0. So to find the point where it's horizontal tangent, we have to find the slope, the equation for a slope, and set it equal to 0. We have to find where the slope is 0. So once you find that, set it equal to 0, solve for x and y. It's asking for a point. So for our equation, it's 6x squared plus 2x minus 9. The slope, 6 times 2, 2 minus 1, 2, that's x, and that disappears. So it's 12x plus 2. Set y prime equals 0, so we have 12x plus 2 equals 0. Solve for x. We have 12x equals negative 2. Divide by 12. X equals negative 1 over 6. So that's the x component. To find the y component, plug x into the original equation. 6x squared plus 2x minus 9. Okay, so I plug in x, negative 1 over 6, anywhere I see an x. Squared makes it positive. Squared both of those, so it's 1 over 36. Positive times negative is a negative. 2 goes into 6 3 times. So those cancel, so we have 6. So what we have right now is 1 over 6 minus 1 over 3 minus 9 over 1. Get a common denominator. Let me come over here. So 1 over 6. The LCD is going to be 6. So here, what times 3 equals 6? I have to multiply top and bottom by 2. So it's minus 2 over 6. What times 1 is 6? 6. So we have 54 over 6. Since we have a common denominator, we don't have to worry about the top. 1 minus 2 is negative 1. Minus 54 is negative 55 over 6. That's the y component. So our answer is at negative 1 over 6, negative 55 over 6. That's the point where the horizontal tangent. And let's look at the last one. What is the rate of change of the area of the square? The area of a square is the base times height. Since it's a square, they're both the same size, so it's x squared. When s is 9. So that's the area. The rate of change is the first derivative. Bring the 2 down. When s equals 9, not 19, 9 equals 18. All right, so that does it for the section number 1. Good luck, everybody.